Way before Ferris wheels were in every carnival and every amusement park in the world, there were just two. One of them was, the very first one was where it got the name Ferris wheel at the 63 World Fair in Chicago. Okay, that was the very first Ferris wheel, and it blew everybody away. They were like amazed. It was more amazing than the Eiffel Tower at the time. And then Paris in the 1900 World Fair decided that they wanted to do it one step better, and they made an even bigger one, right? So it's called the Grande Roue de Paris, and I think it's a fun little setting for some more practice with Newton's second law with circular motion, okay? So I say here the first Ferris wheel in the world. It's actually a lie. It's the second. And it was called the Grande Roue de Paris, and it was built for the 1900 World Exposition in Paris. Imagine a student of weight 667 newtons riding the Ferris wheel, sitting upright, and at the highest point, the magnitude of the normal force on the student is 556 newtons, okay? So let's do a little free body diagram action. So we have this Ferris wheel, right? Okay, and we have a car and there's someone sitting at the top, right? Okay, and we have here a couple things. We have his weight, right? We know that he's got a weight of, well, we're just going to call it W for now, right? And then we know that we have a normal force pointing upwards, right? True story? Okay, and down here at the bottom, he's going to have the same sort of thing. So here he gets down here at the bottom, right? And this person has a weight and, again, a normal force. Okay? Now, will they be the same? Think about it. I'm just going to call this N1 and this N2. We'll see. So the question is, what is the magnitude of the normal force at the highest point and the lowest point? Okay? And that's a hint that they're not going to be the same. The question is, why would they not be the same? Why would the normal force change? And you can almost kind of feel why it might change, because as you go over the top of the Ferris wheel, you get that kind of light feeling in your stomach, right? Like you're a little bit weightless for a second. You're not weightless, but what's really happening is that there's less of a normal force, so you don't feel supported by the bottom of the Ferris wheel as much, right? And at the bottom, I don't know if you guys noticed this, but if you're zooming through, you feel a little bit heavier, almost like the seat's pushing up on you. Why is that? The answer is Newton's second law in circular motion. So if I just say, again, summation of forces here in y equals may, right? And this is for the top situation. Okay? Then I have n going up, right? I have my weight going down. Okay? And this all has to equal mv squared over r, right? And the problem says a couple things, right? It says that the normal force up here at the highest point is equal to 556, right? And it also says that the student's weight is 667, okay? This allows us to calculate the centripetal force, right? But here's the thing. Just like in the last problem, we know that at this top point, the centripetal force has to be pointing down, so I need to remember to put a little negative sign right there, okay? And so I now can say 556 minus 667, flip the sign because there's a minus sign there, right? And that means that my mv squared over r, right, must be, I get a value of negative. Actually, it's going to, in this case, it's negative, but the magnitude will be 111 newtons. Okay? All right. So, quick little recap. What did I do there? Well, I'm just using what the problem gave me, right? That I know my normal force and I know my weight up there, so that I can find the centripetal force. Why do I want to do this? Because at the bottom, if I want to find my new normal force, right, which is what the problem's asking, what is the normal force at the highest and the lowest point? The problem actually gives you the magnitude of the normal force at the highest point, which is 556. But what is it going to be down here? Okay. Now, in order to do that, right? So that's one Newton's second law equation. And if I just do summation of forces in y equals may over here, right? And I want to solve for my normal force at the bottom, this N2. In order to do that, I need to know the centripetal force at this point because, right, it's just N2 minus W equals, again, mv squared over r, right? So if I'm going to solve for this, I need this. I need the centripetal force. But the centripetal force doesn't change. This mv squared over r is the same all the way around because the velocity is constant, right? The Ferris wheel is constantly moving at the same speed, and r is constant. It's always the same radius, right? So that doesn't change, but this guy is going to. Why? Because the centripetal force is pointing up at the bottom. It's positive, right? So instead of, your normal force being, minus mv squared plus w, right, by solving for n, in this case, it's going to be, your normal force is going to be equal to mv squared over r plus w. Right? That means both of these are positive. Here, the centripetal force is negative. Here it's positive. That's why you feel lighter at the top, but heavier down there at the bottom. Okay? So my N2 is just going to be, well, my mv squared over r is 111, right? Positive, pointing upwards here, right? Because I'm at the bottom, and centripetal force always points towards the center, right? Plus the weight, which doesn't change. Obviously, the weight of the person stays 667. Okay, which means that I have a normal force of 778. Okay, and so the final question just asks, where do you feel the heaviest? Well, clearly at the bottom, you feel the heaviest because your normal force, like your butt's pushing back up on you at 778, right? And at the top, right, your normal force is only 556, so you actually feel a bit lighter, right? And this kind of explains why when you're like skydiving or in free fall or going down a roller coaster, you feel that weightless feeling, okay? That weightless feeling isn't that you're actually weightless, right? You always have a weight of mg no matter what. The only difference is you don't have a normal force pushing up on you, right? So the lower that normal force, right, that's resisting your motion, the lower that normal force is, the more you feel what we traditionally call weightless. Right? And the more normal force you feel, the more heavy you feel, the more actually you get a sense of your own weight because you have something pushing on your butt telling you how much more weight you have. Okay? So, yeah, I think that's all I have to say about Ferris wheels. I'll see you in the next video to talk about the difference between centrifugal and centripetal forces.